So let's say combination. So what does combination means? Combination means selection of objects where order of selection does not matter. Order does not matter. So suppose n objects and you have to select r objects from it, and you are asked with the number of ways of selecting, so it will become NCR, where n is the total number of objects, distinct objects, and r is the r objects are to be selected. So then we are having NCR ways. So let's understand this by an example. So for example, you have 4 objects and you have to select 2 objects from it. 2 objects you have to select. So you get 4C2 ways. That is, at first I will define what is NCR formula. So its formula is n factorial divided by n minus r factorial into r factorial. So here 4C2 will give us 4 factorial divided by 4 minus 2 will give us 2 factorial, and r factorial, that is 2 factorial. If you further solve this, you get 4 factorial is 1 into 2 into 3 into 4 divided by 1 into 2, that is 2 factorial, and 1 into 2, 2 factorial. So this is 4. So 4 will get cancelled from here. So you will get 6 ways. So now let's verify that if we select 2 objects from 4 objects, we get 6 ways or not. So for verifying, let's say you have 1, 2, 3 and 4 object, and you have to select 2 objects from it. So you can select either 1, 2, you can select either 1, 3, you can again select either 1, 4. Then if suppose other type of selection, you can select 2, 3, and you can select 2, 4, and finally you can select 3, 4. So you can see that if you try to select 2 objects from a 4 object set, so you are having total 6 ways of doing so. 6 ways. So but in case suppose whenever you are given with very large number sets, suppose you have to select you have 15 objects and you have to select 2 objects from it, selection. So in these cases manual counting is very difficult. In that case we directly write is 15C2, which is 15 factorial by, this is 15 factorial, and this is 15 minus 2 factorial and 2 factorial. So this is 15 factorial divided by 13 factorial into 2 factorial. So this will give us 14 into 15 by 2, that is 7 into 15, which is 105 ways. So you can see the benefit of this formula. So it saves you from manual counting. And just think about it, if you count 105 ways, what will happen? You will be extremely exhausted. So now let's see some special cases of combinations. So the number of ways of filling R seats out of n seats when k seats are already filled. So here what we have done, that n minus k c r minus k. So earlier we have seen that n c r. So here what we have done, that we have subtracted k from the top and from the bottom. So why we are doing so? So we will understand this by the example. Suppose what are the number of ways of selecting 11 players out of 15 players, considering that captain and vice captain are already being selected. So here 2 people are already being selected and there total 15 players are there, and you have to select 11 players from them. So but out of these 15 players, 2 are already selected, so we will subtract 2 from both. So because now only we are having 13 players left, and out of 13 we have to select only 9 players. That's why we have this formula, n minus k c r minus k. So let's see the second special condition for combination. So the number of ways of selecting at least one object out of n objects. So here you are given at least one object. So if n objects are there, then to select at least one object, you can either select only one object, or so in case of or you will add a plus sign, or you can select two object, or you can select three object, or you can select four object. So similarly you can select n objects. So if you go for the summation of these entire expression, then by binomial theorem you will get the formula as 2 to the power of n minus 1. So let's not go deep into this derivation of this, how this formula comes. So just remember the result. So whenever you are asked to find the number of ways of selecting at least one object out of n objects, so you will directly write this. So for example, if you suppose take 10 objects are given, and you have to select at least one object. So how many number of ways will be there? So in that case, one, either you can select one, either you can select two object, either you can select three object. Similarly you can select all the 10 objects. So the summation will be 2 to the power 10 minus 1. So this is the final answer. So this is the number of ways in which the at least one object can be selected from a basket of 10 objects.